What is the mass? We're trying to solve for the mass, right? Of a cylindrical 2.3 meter radius merry-go-round. If we exert a force of 45, oh my God, 32 seconds, it accelerates to a speed of, okay, so this is definitely our change in W, right? This is definitely our time. Okay, tangentially, 45 newtons tangentially. Okay, so two things we got to do. The first thing we're going to do is find the torque. The torque is RF. If it's tangentially, it's of course what, perpendicular to the radius. So, right, because of math. Okay, so the torque is equal to 45 newtons times 2.3 meters. 45 times 2.3 is, well, that's a lot of torque. Okay, so that's 103.5 meter newtons. Okay, that's our first thing to do. The second thing to do, I guess what we're going to do, is we're going to solve for I, and then we'll from there solve for what the mass is. Okay, so the next thing is use this guy to torque times time is I times change in angular velocity. So the torque is 103.5 meter newtons. Our time is 32 seconds from here, right? Okay, 103.5 is there. Our moment of inertia is what we're solving for, and our change in angular velocity is 1.5. Okay, so let's find what I is. Sounds like bad grammar, but it's not. All right, so times 32 divided by 1.5. So I is 2208. 2208 kilogram meters squared. Okay, so now let's set up an equation for the mass. Since it's a cylindrical merry-go-round, right? As opposed to those thin ring ones, right? Our moment of inertia will be found by this formula, 1/2 mr squared. So 2208 kilogram meters squared is equal to 1/2 our mass. Oh, mass is what we're solving for. What's our radius? 2.3? Okay, so let's see if we can solve this for mass. So I'm going to go 2208, I'm going to go times 2 divided by 2.3 squared, and I'll have the mass. There it is. So my mass is 834.78 kilograms, approximately. All right, that's like the mother of all angular momentum problems.